Hello friends, today we are going to study some basic concepts of electricity. Let's start the video by assuming an imaginary investigator. Our imaginary investigator found one day that touching the two poles of battery by his two hands, he feels something. Let's name this something electricity. Next, our investigator one day found that by putting copper sulfate in a vessel and immersing two copper electrodes in it and by connecting it to a source of electricity, he notices that some amount of copper is deposited on one electrode. He notices that the mass of deposited copper is proportional to the amount of charge flowed. By equating, we can write it as now our investigator is capable of taking the quantitative measure of charge flowed. Now our investigator proposes that the amount of charge flowed per unit time is current. Next, one day our investigator connects different materials to the same source of electricity. Let's say one day he connects copper rod to a battery. He notices that copper heated up. Next, he connects an iron rod with the same source of electricity. He notices that the iron rod heated much than copper. Next, he connected chromium rod with the same source of electricity. He notices that chromium rod heats much than iron rod. Now our investigator knows that different types of materials produce different amount of heat when connected to a same source of electricity. Let's say a unit piece of a wire produces Q amount of heat when connected to a source of electricity. One another day, our investigator found that by connecting same material to different sources of electricity produces different amount of heat. One day our investigator found that the ratio of heat generated to the charge flowed is different for the different sources of electricity. Uh, let's say this charge ratio is equal to V. Let's name this voltage. We can say the higher the voltage, the higher the amount of heat generated. By using the previous equation, we can write Q is equal to Q times V, or the amount of heat generated is equal to V I T. Next, our investigator found by conducting several experiments that voltage is proportional to current. By equating, we can write that voltage is equal to this. By using equation number 3 and 4, we can write the amount of heat generated is equal to V square upon R times T. And we can also write that the amount of heat generated is equal to I square RT. You might have noticed that Q should be proportional to R. If I square times T is constant, similarly we can write Q is inversely proportional to R if V square times T is constant. Now we can say that Q is strictly proportional to R at constant current. and Q is inversely proportional to R at constant voltage. You might possess the question that how is R related to the shape and size of the conductor? Our investigator conducted several experiments and found that R is proportional to the length of the conductor and inversely proportional to the area. By equating, he can say that R equals L upon A, where rho is called resistivity. By equating equation number 4 and 5, we can write V upon I is equal to rho times L upon A. By applying simple algebra, we can write I is equal to V times A upon rho times L, or we can write I upon A equals 1 upon rho times V upon L. This ratio has a specific name. We call it current density and is denoted by J.